Hello. Welcome. Before I get started explaining, I'd like to first mention, there is no need for laser levels, or any type of level. You don't need a Nikon P900, telescope, or any of that expensive stuff. The only materials needed is a flashlight, hose pipe, 3 support poles, and some water. This diagram shows a hose pipe filled with water, running along the ground for a distance of 1 mile, with 3 hose pipes connected vertically from the hose pipe on the ground, which are held up with posts. The distance can be less than 1 mile, but everyone is familiar with the measurement 8 inches per mile squared, so for this example, we will suppose the hose pipe is laid out on the ground for 1 mile, with the 3 vertical connections. 2 connections are at each end, and 1 at the center, which is 0.5 miles. This hose pipe does not require that it be leveled, as the water will find its level up the vertical connections, and level out, giving us a water level at 3 different points. The water level on the center connection will represent the horizon/point where the target goes behind the curve. You can see from this angle that the water level at the center connection is higher, relative to the connections at either end. Now obviously, in reality, doing this test at the distance of 1 mile, you wouldn't be able to observe this. You would see absolutely fuck all. But, having said that, we should still expect to observe the curve over a distance of 1 mile, doing this test at night, using a flashlight. Now, let me show you how. Bear with me, as I fit the flashlight at the end connection. Mir. That was my Conor McGregor impression? I hope you liked it. Now, let's fit the flashlight. We will fix it against the connection, flush with the water level. Now, we need a piece of cardboard to fix at the water level on the center connection. You will understand why now in a second. Looking damn good. So, you will see now that we cannot see the flashlight from the observation point, because of the cardboard blocking our view from the water level at the end connection. Hence the curve, as we would expect in reality. So we have 2 options now. Either raise the observation point up 9 inches, or move the cardboard down 9 inches, essentially taking the curve out of the equation. I assume the cardboard should be moved down below 8 inches, to maybe 9 inches before you can see the flashlight. 9 inches may be necessary because the flashlight is not on top of the water level. Up and down you go? Up and down you go? It certainly seems a lot easier than doing tests with lasers along rivers and across lakes. No refraction, as I mentioned a second ago. You can also raise the observation point up 9 inches and expect to see the flashlight over the curve. Also, if you were to plug the center connection shut, you could push the water down 9 inches at the observation end and expect to see the water level at the end connection rise above the curve. Now, let's summarize. This is what we should expect to observe on a globe. If you are wondering why I have placed the flashlight flush with the water level under, instead of on top, it's so that you can move the cardboard down slowly, until you can just see the edge of the flashlight. This point represents the water level at the flashlight. So the cardboard should measure close to 8 inches below the water level at the center connection. This would not happen on a flat plane. It is fair to say there is many ways to approach this. I've certainly seen a lot more effort put into other curvature tests that seem impossible to begin with. I look forward to hearing feedback on this, and see it being put to the test. So, if you liked this video, and understand the demonstration, then smash that like button, leave a comment, and don't forget to subscribe. There's more good stuff on the way. Now, take care, and be good. Peace.